Parallel lines. Parallel lines are lines that don't intersect. So like this, kind of like railroad tracks. And so because they're not going to intersect, then what happens is you have the same rise over run for both lines. So their slopes are the same. Same slopes. Same slopes. So sometimes we'll call this like line 1 and line 2. And so the slope of line 1 equals the slope of line 2. So if you have two lines and you know their slopes and they have the same slope, then those lines are parallel and means they don't intersect. They're like railroad tracks. Okay. So that's the deal with parallel lines. So this says, example 10 says, use slopes and y-intercepts to determine if the lines are parallel. So what you have to do is you have to know the slopes and the y-intercepts. So we'll talk about the y-intercept in a minute. Well, let's talk about it now. So if I go up here and I have line 1 and line 2, and let's say, here's my graphing system, you can see that their y-intercepts are different, right? Okay, so if they have the same slope, but different y-intercepts, then they're parallel lines. If they had the same y-intercept, then they would just be the same line, and that happens sometimes. So you might think, well, why would you have two equations that are the same line? It happens. So that's why it says in our example, use slopes and y-intercepts to determine if the lines are parallel, because you might just have one line instead of two. Okay, so let's look at our first example example 10, part A. And so this first equation, we don't know what the slope is by looking at it, so we're going to have to solve for it. So I'm going to take that 2x to the other side, and I'm going to have 5y equals negative 2x plus 5. So I want to put it in slope-intercept form. I'm going to divide by 5, divide each term by 5, and I get y equals negative 2/5 x plus 1. So what we've done is we've put that first equation in slope-intercept form, which is good. Now we know what the slope is and we know what the y-intercept is. The second equation over here, it already has it in slope-intercept form, so good. We don't have to do that part. It's already done for us. Now, do they have the same slope? Yes. Do they have different y-intercepts? Yes. So these are parallel lines. Parallel lines. So, yeah, that's the answer. Yes, those are parallel lines. Okay, so now we'll go to the next one, B. The first one is in slope-intercept form, so we know the slope's negative 1/2, and the y-intercept is negative 1. But the second one is not in slope-intercept form. So we're going to take the x to the other side. When we do that, it becomes negative. We're subtracting x from both sides. And then we're going to divide everything by 2, divide both sides by 2. And we get y equals negative 1/2 x minus 1. Okay, so this time they have the same slope. So there's the slope, m. There's the slope for this one, m. Those are the same, but the y-intercepts are the same. So these are actually the same line. So same line. The equations look different, but they have the same line, and so they're not parallel lines. Not parallel, because you just have one line. I hope that makes sense. If you only have one line, you don't have two different lines being parallel, so they're not parallel. They're the same line, which is important too, but they didn't ask about that. They just want to know if they're parallel lines. Okay, use slopes and y-intercepts to determine if the lines are parallel. Well, in part A, you have y equals 8. Now, remember, this one, there's no x term, so that means it's a horizontal line, right? And this one says y equals negative 6. That's also a horizontal line. So are those parallel? Yeah, those are parallel. Okay, in part B, you have x equals 1. So this time there's no y term, so it's a vertical line. And this one says x equals negative 5, so it's on the other side, but it's also a vertical line, right? And are those parallel? Yes, those are also parallel. So you just have two vertical lines. Okay, so that was fun.